Hello. In this video, we will review NextLabs Data Access Enforcer for BigQuery, which uses an attribute-based access control platform. DAE for BigQuery provides users fine-grained access control to the different resources in BigQuery, such as dataset, table, record, and field. For the purpose of this product demonstration, we have prepared a sample dataset called BigQuery Demo. This dataset is a simplified sales schema following a star pattern with the sales table at its center. The sales table records the different sales transactions across the different locations we have. The branch table keeps some information about the different offices and the people in charge. The customer table keeps track of some customer data that we can use to generate demographics reports, including age and gender. The item table keeps track of information about the products being sold. The location table keeps track of the different locations that the organization does its business in, including its headquarters in New York, the different branch offices, and pop-up stores. The times tables break down the purchase date into days, months, years, and quarters. Based on the locations table in BigQuery, our demo company has a total of 10 locations. 2 retail locations in New York, 2 retail locations in California, 3 retail locations in Illinois, and 2 retail locations in Texas. All locations are managed by the headquarters in New York. For this demo, we will have a couple of test users from select locations stored on our use cases. We will be using Tony from the head office in New York, Linda, who is the branch manager of our retail location in Madison Avenue, and Joy, who is the branch manager of our retail location in Lincoln Park in Chicago, Illinois. These users are stored in a separate data store. This could be your Active Directory or any other identity provider. The users will contain the following attributes in the identity provider. These attributes will be used later when we make policies to control the access of these users. For now, let's look at the reporting tool that we will be using to access the data that we have in BigQuery. We have prepared a simple Python script that connects to the datasets we have in BigQuery and fetches the data using SQL statements. You could use any other third-party reporting tools with DAE for BigQuery, as long as it allows us to redirect the connection from the Google API to our DAE proxy. We'll discuss this in more detail in a few minutes. In this demo, we have decided to use this tool simply because it allows us the convenience of easily switching to a different user each time a new report is generated. Let me show you what I mean. When I run this script, it asks us to provide a username. In this case, we just need to specify the login name. Of course, in real-world environments, you'll be asked to authenticate the user first. Probably put your username and password, or if your BI tool supports single sign-on, then you don't have to worry about the login process. It then asks us which report you would like to generate. Then, it will make a connection to BigQuery and fetch the information that we need. This process keeps on iterating. If I use another account and run the same report, you will see that I will get the same results. Again, I will run this as a different account, generating the same report, and I get the same results. Now, let's see how we can use DAE to control the information being displayed to each of these users. First, let's take a look at the Python script. The first part simply loads all the Python libraries. The second portion establishes a connection to BigQuery. The connection makes use of a JSON file where BigQuery service accounts credentials are stored. This is one of the standard methods of BigQuery uses to connect third-party applications with BigQuery API. All the scripts in this section are all BigQuery standards. The next section simply defines a function to run an SQL statement in BigQuery. It accepts an SQL statement as a parameter, connects to BigQuery, and executes the SQL statement. This function also prints out the results set and generates a quick summary of how many rows were returned. The last section defines the main function of our script, and it does the following. First, it defines the SQL statements of our predefined reports, and then it presents a UI that repeatedly asks the user to specify the UID. It then prints out the predefined report options and executes one of the predefined SQL statements based on the user's selection. In order for me to connect this reporter to DAE, all I have to do is point the connection URL to our proxy server. On top of this, I'll also send the login username as part of the request. I will save the script. Now that our reporting tool is connecting through the DAE proxy, let's see how this will affect the results that each of the users will acquire. First, I will log in as Tony and I will choose report number 1. You will see that Tony has 10 rows for this report. Let me try to run this report again, but this time using Linda's account. For that same report, Linda does not have any results. Let me try this with Joy's account. Joy does not have any results. Now let me try to run a different report. For report number 5, you will see that Tony has 29 rows for this report. Now let's try this report using Linda's account. For Linda, she only has 4 rows, and you will notice that all these rows come from Madison Avenue. Let's try this with Joy's account. Here, Joy has 3 rows, and all these rows come from Lincoln Park. Now that this reporter is connecting via our proxy, our users are getting results based on the policies we have defined for them. This concludes our video introducing DAE for BigQuery. In other videos in this playlist, you will learn how various deployed policies enable DAE for BigQuery works to restrict access and dynamically segregate and mask data to protect sensitive information.